This is section 7.2, and in this section we're going to solve linear systems by substitution. Now you remember, we watched a video yesterday, and in that video we learned what a system was. A system of equations, remember, is when you have two or more linear equations with the same variables. And to solve a system, you're trying to find what's the ordered pair that you can plug into each system that will satisfy each at the same time. Okay? We worked on solving systems by graphing yesterday. Now graphing isn't hard to do, but I would say it's kind of a major inconvenience. There are other ways to solve a system where I would say we don't have to graph. It's a lot, I don't know if I want to say easier, but it takes away the headache of graphing, and one of them is a method called substitution. So I think the easiest way to show you how to substitute would be to do the following. First of all, take a quick peek at page 435 in your book. I'm not going to write this on the screen, but please look at page 435, and at the top of the page you'll see a blue box that's going to have 3 steps to solving a system by substitution. And I'll read through them, and then we're going to actually go through a problem and carefully follow each of those steps. You're going to get to hear this twice. Here are the 3 steps. Solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1 or negative 1. We'll show what that means in more detail in a minute. Number 2, substitute that expression from step 1 into the other equation and solve for the other variable. And step 3, substitute the value from step 2 into the revised equation from step 1 and solve. Now you might be like, what the heck is that? Okay, it's 3 simple steps, but it's easier to show you than read it. Okay, so I'm going to show you by going to page 439. Why don't you go to page 439, and let's go to problem 4, and we're going to follow those steps. Okay, now actually I broke it into even more detail to make sure that if you have any confusion, that this is going to be easy to follow. So first of all, number 4, here's our 2 equations. We have y equals 2x minus 1 and 2x plus y equals 3. I wrote them in different colors to make it easy to track. Now, here's the first thing. The first step is to isolate a variable in one of the equations first. Now, you got to be careful with this stuff. I'm going to put a little star next to it, okay? We got to have one of the equations isolated for either y or x. I don't care which one. Now, look carefully at each equation. Sometimes you're going to get lucky, like in number 4, we got lucky. One of these equations are already isolated for one of the variables. Do you notice how the black equation, y, is already isolated? So this first step is already taken care of for us in number 4. We already have one variable isolated. Okay? If one variable isn't isolated, pick the easiest equation to isolate. We'll talk about that more in other examples. So now that's step 1. I already have an equation isolated. Now step 2. Since y, now think about this carefully, y is equal to 2x minus 1. Y and 2x minus 1 are the same thing. So what I can do is I can go to the second equation. I labeled these A and B. So in equation A, y and 2x minus 1 are equal. They're the same. So if I go to equation B, where I see y, you see y. I can substitute, this is where the word substitute comes from, I can substitute 2x minus 1 in for y because y and 2x minus 1 are the same thing. So look down here, can you see that? I have 2x plus, I substituted 2x minus 1 in for y equals 3. This is what substitution, that's why they call this method substitution. Now all I need to do is solve this. Let's solve. That's step 3. I got to solve for the missing variable. I'm going to solve for x. Let's do that. That should be pretty easy. 2x plus 2x minus 1 is 3. Remember, simplify first. So 4x minus 1 equals 3. I can add 1 to each side. So 4x equals 4, which means x is 1. We just found out that the x value of our ordered pair is 1, but I still got to figure out y. That's very simple to do. So now my next step would be, I got to get to the next page. My next step would now be to say, since x equaled 1, since x equals 1, plug 1 in for x in either equation and find the other unknown. So I can take 1, I could plug it in right here if I want to, and find y. Okay, so I'll do that. Y equals 2 times 1 minus 1. 2 times 1 is 2. 2 minus 1 is 1. I just figured out y is 1. So x equals 1 and y equals 1. The solution to this system is 1, 1. And I ought to quickly check it. Let's go back to the previous slide and check if 1, 1 works. Well, I'll do that. Well, I already know if I plug in a 1 here and a 1 here, that works because 1 equals, well, 2 minus 1 is 1. And if I plug in a 1 here and a 1 here, that works. 2 plus 1 is 3. So 1, 1 is a solution. So I wrote it in 4 steps. The book said 3. The book combined basically step 2 into 2 steps. My step 2 and my step 3, that's the book step 2. So I wrote it in 4 steps. The book wrote it in 3. They just took step 2. All of this here was what the book said was step 2. I just broke it into 2 little steps, okay? That's how we substitute. I think it's a simple process. We probably just need more practice on it. Okay, so let's go to number 12, and let's follow those 4 steps again that I gave you. Book gave you 3. I just broke it into 4 more detailed steps. So the first thing we have to do is get a variable by itself, and there's a little skill to this. We want to pick the easiest thing we can to get by itself. So I'm looking at this carefully. You notice that in the first equation, if I just quickly take away 2x from each side, I just got y by itself. So that's what I'm going to do. I'm going to get y by itself in the blue equation. Okay? By the way, in number 12, you can see I wrote one of the equations in blue and one in black. I just do that to make it easy to follow. So I got the blue equation isolated for y. So y and 9 minus 2x are the same thing. So now I can go to the black equation, and I can substitute in, that's where that word substitute comes from, I can substitute in 9 minus 2x for y, because y and 9 minus 2x are the same thing. So can you see that in the black equation I have 4x minus 9 minus 2x is negative 15. Okay, so from there, I have to distribute, so I have 4x minus 9 plus 2x equals negative 15, and now I can simplify solve. So simplifying, I have 4x plus 2x is 6x, minus the 9 is negative 15. I can add 9 to each side, which gives me 6x equals negative 6. I can divide by 6 on each side, which gives me x equals negative 1. I now found out what x is, but I still got to find y. I got to figure out what's y. Very simple to do. Take negative 1, plug it into one of your original equations. I'll plug it into this one. Well, if I plug in negative 1 for x, I have negative 2 plus y is 9. Well, negative 2 plus 11 would equal 9, so I know right now that y would have to be 11. So negative 1, 11 is my solution, and I can just plug in negative 1, 11 and check it in each. I already know it works here. If I plug it in here, negative 1, 11, I get negative 4 minus 11 is negative 15. It checks there. I just solved the system by substitution. Let's go to number 16. Here's the problem. Solve the system by substitution. I wrote one equation in black and one in blue just to make it easy to follow. Now remember, I have to get a variable isolated. It doesn't matter which one, x or y. Pick the easiest one. So look at both equations. Do you notice right here that x is, if I just take away 2y, x would be by itself. That would be very easy to do. So that's what I'm going to do. I'm going to get x by itself. I'll just take away 2y from each side. I just did that. If I take away 2y from each side, I will have that x is 1 minus 2y. So I have now isolated x. So that means x and 1 minus 2y are the same thing, which means now I can substitute. Remember, here comes that word substitute again. That's why they call this substitution. I can substitute 1 minus 2y in for x in the black equation, because x and 1 minus 2y are the same thing. They're equal. So I'm going to take 1 minus 2y, and I'll substitute it in for x. So I have 20 times the 1 minus 2y minus the 30y equals negative 50, and now I can simplify and solve. So simplify means distribute here first. Combine like terms. Do we see how we had like terms here, and that's negative 70y. So I have 20 minus 70y. That is a y there. It's not well written. Let me see if I can, there we go, a little bit better. That is a y. So I have 20 minus 70y equals negative 50. Of course, I got to take away 20 from each side, which gives me negative 70y equals negative 70. And I can divide each side by negative 70 real quick, and that's going to give me 1. So y is 1. Now to find x, if I plug in a 1 here, to find x, what plus 2 is 1? Well, negative 1 plus 2 is 1, so I know x has got to be negative 1. All I got to do is check it. I got to plug in, if I plug in negative 1 and 1 here, I already know it works. Let's try it here. If I plug in a negative 1, I get negative 20. If I plug in 1, I get 30. Negative 20 minus 30 is negative 50. That checks out. Substitution. 22. Let's solve 22 by substitution. Again, I got to get a variable by itself, and I want to pick the easiest thing to get by itself, okay? Like, for example, I wouldn't want to get x up here by itself because I'd have to add 2y and then divide everything by 3. I'm going to get a mess. That's not good. But look right here. If I just take away 0.5x, I'd have y by itself. So that's what I'm going to do. That's the easiest thing I can do real quick. I will take away 0.5x from each side, and that will get y by itself. Take away 0.5x. There's y by itself. So the blue equation, y is by itself. Black equation, I can now substitute. So since y and 17 minus 0.5x are the same thing, here comes that word substitute again, I'm going to take 17 minus 0.5x, and I'm going to substitute it in for y. So here I go. 3x minus 2 times 17 minus 0.5x equals 8. I can, remember, simplify would include distributing and combining like terms, so I distributed. Don't make any sign mistakes here. Remember, this is a plus here. Negative 2 times positive 17 is negative 34. Negative times negative is positive 1x. And then I have like terms. 3x plus 1x is 4x. I still have the minus 34 equals 8. I can add 34 to each side, divide by 4. I just got x is 10 and a half. And once I have 10 and a half in for x, I have 10 and a half for x, I can go right here, and I can take 10 and a half and plug it in. So if I have 0.5 times 10 and a half, that's 5.25, plus the y equals 17. And if I take away 5.25 from each side, what I'm finding out is I'm getting y equals 11.75, which is where I got that. So there's my ordered pair. All I have to do is check. Let's do one last one here, or a couple last ones. 20, here's my first equation. Here's my second equation. I want to substitute to solve this system. So the easiest thing I can do is if I just quickly add y to each side, do you notice how x is immediately by itself and I didn't have anything hard to do? So I just got x by itself. X and 4 plus y are the same thing. So now I need to substitute. That's why they call this substitution. I'm going to take y, 4 plus y, and I'm going to substitute it in for x. So I'm going to do that here. I have 4.5 then times the 4 plus y plus 1.5 equals 2.4. I can distribute. I can combine like terms. I can subtract 18 from each side. Divide by 6. I get y equals 1. And if y equals 1, then 5 minus 1 is 4. So I know x has got to be a 5. And then I can check it in the other equation. Make sure that it satisfies both. Okay? One last problem to do here, 28. Now this one's a little bit uglier, as you can see. This doesn't look nice at all. I want to substitute here, and there isn't any easy way to get y or x by itself, so I think what I'm going to do is I'm going to try to get x by itself in this equation, so I decided to take away half y from each side. This is where substitution can get a little messy because I don't have an easy way to get x or y by itself, so I took away half y from each side, and you'll notice I get 2/3 x equals 13 minus half y. I divided everything by 2/3, and I used my calculator. Remember, I broke this into separate fractions. This is 19 and a half. And negative half y divided by 2/3 is negative 3y. Okay, now I got to substitute that. So since x and 19.5 minus 3y are the same thing, I can now substitute, there's that word again, substitute. I can substitute 19.5 minus 3y in for x, which is going to give me this. I can distribute. This is ugly, so I got these fractions in here. I can distribute. I can combine like terms. And then from there, I'm not going to finish this one up. I'll let you finish it. You now need to solve for y, find out the value of y. You can do that by taking away 7 and 5/16 from each side. Solve for y. Once you've solved for y, take y, plug it into one of these original equations to find x, and finish it up. So this is where substitution isn't as convenient, but honestly it doesn't matter if we graph or what method we did. When we get these fractions in there, we have to work our way through the fractions, okay? So anyway, that should get you going on today's stuff. If you have any questions when we come to class tomorrow, we can start class by going through those.